Welcome back to another lecture on OpenDSS G. I'm Davis Montenegro, the creator of the tool, and in this session we'll focus on understanding and using the customized reports introduced in OpenDSS G version 7. The goal is to give you a clear step-by-step sense of what these reports are, how they differ from the default OpenDSS outputs, and when to use each option during your analysis workflow. OpenDSS G has always offered multiple pathways for accessing simulation data. But before exploring the new reporting features, it helps to recall the three existing mechanisms. The first one refers to the default OpenDSS reports. These are built-in reports generated by the OpenDSS engine. In OpenDSS G, you can access them through the report subpalette. They provide raw engine-level outputs such as element losses, voltages, currents, powers, and other electrical information. The second one is the Quick Measurements window. This offers immediate at-a-glance values for selected elements. It's ideal for quick checks during model setup or debugging. It shows electrical quantities as well and can be exported to Microsoft Excel or copied into the clipboard. The third option will be using the export command via the scripting tool. Using the export command, you can generate CSV-style outputs directly from OpenDSS. This is useful when you need full control over the data format or want to integrate results into external tools. These three methods form the foundation for interacting with simulation results. The Customized Reports tool introduces a guided dialog where you define exactly what information the report should contain. You can select the variables to include, choose the object class you want the report to focus on, and apply filters to narrow the results. These filters can be based on both object properties and electrical values associated with the selected class, allowing you to target only the elements that meet specific analytical conditions. In this example, we'll focus on the load class. Selecting this class automatically populates the report with all available properties and electrical quantities associated with loads. From there, you can refine the report by opening the configuration panel and choosing only the variables you want to include. For this demonstration, the report is configured to show the number of phases, nominal kW, nominal kV, and connected bus, and several electrical results per unit voltage, voltage magnitude and angle, and active and reactive power. With these selections in place, running the report retrieves the chosen information for every load in the circuit model. As you can see, the query executes almost instantly, even for large feeders. Now let's apply some filters. In the Customized Reports tool, filters behave much like query conditions in a NoSQL database. You specify the criteria, and the tool returns only the elements that match. In this example, we're filtering all loads whose per unit voltage or on any phase falls below 0.95. Once the filter is defined and the report is executed, the results immediately show only the loads that meet the condition. We can continue adding conditions as needed. Each condition is complementary, meaning all of them must be satisfied for an element to appear in the report. The results you see are therefore the subset of objects that meet every declared criterion, no exceptions. This makes it easy to tailor the report, add conditions to narrow the scope, or remove them to broaden it, depending on the analysis you want to perform. The final report can be exported directly to Microsoft Excel, copied to the clipboard, or saved as a CSV file for later processing. After choosing the desired option, the report is generated immediately. If you open it in Excel, it appears as formatted spreadsheet. If you paste it into a text editor such as Notepad, it appears as a comma-separated table that can be imported or processed as needed. The Customized Reports tool provides a structured way to extract exactly the information you need from an OpenDSS G model. It lets you choose the object class to analyze, select the specific variables to include, and apply precise filtering conditions that work like query rules. Because all conditions must be satisfied simultaneously, the tool reliably returns only the elements that match your analytical criteria. I hope you found this lecture both clear and useful, and I look forward to having you join me for the next session. OpenDSS G has grown into a flagship platform for exploring and showcasing the full power of OpenDSS. And for more than a decade, it has helped thousands of users learn, experiment, and innovate through an intuitive graphical experience. Each year, we push the boundaries of what a graphical interface for OpenDSS can be, bringing the engine's advanced capabilities to life with richer visualization, smarter workflows, and tools that can accelerate both research and real-world engineering. To amplify that momentum, we've introduced the OpenDSS G roadmap, a dynamic community-driven space where users can vote for upcoming features, propose new ideas, and engage directly with the development team. It is designed to make your voice central to the evolution of the platform and to ensure OpenDSS G continues to meet the needs of utilities, researchers, consultants, and innovators across the industry. As an open source project, OpenDSS G thrives on collaboration. We invite users to share their perspectives, help shape priorities, and, if interested, join as contributors to advance the next generation of graphical tools for power flow simulation based on OpenDSS. Visit opendss.prodcom.com to start your journey helping to shape the future of OpenDSS and OpenDSS G. Thank you.